horizontal asymptote, which is y equals 1. Here it is. I see a vertical asymptote of x equals 3. And now I will graph the function. I will plot negative 1 comma 0, which is this point. I will plot 0 comma negative 1/3, which is this point. And on this side, one more time, it's coming from approaching 1, crossing the x-axis, crossing the y-axis, and going towards negative infinity. On the other side, coming from positive infinity and approaching 1. And this is our function type 1, x plus 1 over x minus 3. With the graphing calculator now, let's check our work. Every time you put a rational function in the graphing calculator, you have to remember to put parentheses around the top and parentheses around the bottom. Otherwise, the calculator graphs something else. So in parentheses, x plus 1 divided by x minus 3. What other function do I have to put in the graph in the calculator because it will not graph it otherwise? I have to put it in. The calculator will not.
Horizontal.
Exactly. Y equals 1. It will not graph it. I will use the standard viewing window for now. And here it comes. Crossing at negative 1, 0, crossing at 0, negative 1/3, and here's the horizontal asymptote. And the end behavior, 1 on both sides. This is type 1. Type 2 is even easier than type 1. All the same, but easier. And here's the reason why. One more time, what is the horizontal asymptote for type 1? How do we get it? Leading coefficient over the leading coefficient. The only difference for type 2, which is easier, the horizontal asymptote will be 0. Why? Because the denominator is stronger than the numerator. At infinities, it will approach 0. That's the only difference. Only difference. So let's make one up. Can anyone? Or we can use the one that I made up. Okay, let's go back. I don't remember what I made up. Okay, so it's x plus 1. It's a good one. X plus 1 divided by x squared minus 1. Very good. Okay, what type of function is it? And the answer is a rational function. Correct, perfect. Rational function type 2. Because the degree in the denominator is bigger than degree in the numerator. Good. What do you think I'm going to do here first? True, but before I find the domain, I need one more tiny step. Right?
I was going to say, not separate the denominator, but.
Exactly. What do I have to do to it? You are on the right track, but factor. Awesome. Because that's the only way I can determine the domain. Very good. Awesome. Good. So the top is x plus 1. The denominator will be? Very good. Remember, we cannot touch anything before we state what? The domain, please. So you're going to give me 2 restrictions this time. And they are? Awesome. You remember that. I'm very happy to see this. Now I can simplify. And I get 1 over x minus 1. Agreed?
Agreed.
Perfect. So now here's my question. This function does not exist for 2 x values. And they are? Awesome. But one of them went away. The other one stayed. The x minus 1 is still there. And no one can erase it. But one of those 2 factors went away. There must be something different, right? The function is still undefined at 1 and negative 1 because we're graphing the original function. But one factor went away, disappeared by simplifying, and the other one stayed. What do you think the difference would be? And let me ask you this. Do you think that x equals 1 will be a vertical asymptote or not? Yes, it stays there. I can't do anything about it. If it's still there, it will definitely be a vertical asymptote. But x equals -1 will not. What do you think will that be? It will not be a vertical asymptote. The function is still undefined. Open point. Open point. So if the factor goes away, it will be a hole in the graph. If the factor stays, it's still a hole in a way, but it's a vertical asymptote. So x equals 1 will be a vertical asymptote. X equals -1 because the factor went away will be an open point or a hole in the graph. Okay, so let's start our chart. We already have the domain. You already told me everything but. Perfect, awesome. -1, 0 has to be in the table. And this is what I have to show, meaning the function is undefined at -1 and 1. Since the factor stays, what do I write under x equals 1? What do I write under x equals 1? What is x equals 1, I should say? Perfect. Since the factor went away, what do I write under x equals -1? X equals -1 whole or an open point. This definitely has infinities and we'll figure out the sign, but this one does not. So let's plug in -1 and give me the numbers left and right. The denominator is -2, the numerator is 1, so what will be the number here? -1 over 2, 1 divided by -2, and on the other side also -1 over 2. Let's figure out these infinities. With -1 minus 1 is -2. 1 over -2 is -1/2. Better? So now let's plug in 0.9. 1, it's positive. 0.9 minus 1. What sign do I get in the denominator with 0.9 on the left-hand side of 1? Negative. So then positive over negative will be? Negative. Very good. Let's plug in 1.1. See, I put these numbers way out of the chart. I'm not going to plot something like that, but I need something very close to check and see the sign. Exactly. So it's positive. Now let's plug in 0 and tell me what you get. Perfect. And what did we decide about the horizontal asymptote and the end behavior? For type 2?
0.
Thank you. Y equals 0, horizontal asymptote. It's done. So let's take a look. It starts at 0 and it goes to infinity. Right here. From 0 to infinity. Then on this side, from -infinity, crossing the y-axis at 0, -1, going through a point that is -1, -1/2, and approaching 0. One more time, from 0 to infinity. On the other side, from -infinity, crossing the y-axis, going through an open point, and approaching 0. Ready to graph? So when I graph a function with asymptotes, what do I have to graph first? The asymptotes. Let's do that. This is an overkill right here. This one is an overkill. Why? Because I already have the x-axis. X equals 1 is a vertical asymptote. And now I have to plot this point. So 0, -1 is right here. But I have to plot this point at -1, -0.5. So let's try again. From 0 going up to infinity. from 0 going up to infinity, from 0 to infinity on the right-hand side of the asymptote, of the vertical asymptote. Then it's coming from negative infinity, crossing the y-axis, going through this point, negative 1 comma negative 1/2 through the hole, and approaching 0. This is the graph of f of x, x plus 1 over x squared minus 1.
Oh, that's a hole.
That's a hole, because the function is undefined at negative 1, as you told me from the very beginning, which was perfect. Let's graph it. Be careful, the calculator is not as sensitive as we wanted it to be. So clear everything. So we have x plus 1. We have to put in the original function, x plus 1, bless you,
Excuse me, thank you.
divided by x squared minus 1. There is no need to graph y equals 0. So I'm going to use the standard again, see what happens. Here it comes. I would like to see that point right here. I want to zoom in to look at this area. So between negative 2 and positive 1, and between negative 2 and positive 1. So negative 2, 1 with a scale of 1, negative 2, 1 with a scale of 1. Graph again. And here it is.
Little gap.
Yes. It's clear that it's not a vertical asymptote because the function has to do this if it's a vertical asymptote. It's not. It's an open point. Any questions? Any questions?